Welcome to all of you, to all of the audience, to our today's web session regarding process data analysis, discovering hidden potentials. This is a big topic, and this is just a topic which is taking much more an interest in the time right now. So we would like to give you a brief overview in this very short time, this very short web session right now, in order to give you an idea of that. As Mr. Bell said, my name is Marcello Mintrone. I'm responsible for the sales department in tool management in company Gühring, and I will give just over to Daniel to present himself for a second.
Thank you, Marcello. Also, warmly welcome from my side, ladies and gentlemen. My name is Daniel Gühring. I'm the head of the tool management projects, and later on during the presentation, I will present to you some practical samples how to use the GTMS for the process data analyzation. Thank you, and back to Marcello.
All right, ladies and gentlemen, let's step in. About the content of the presentation, I will talk about and show you some basics about data analysis, especially in cutting operations. Then we will talk about some technical requirements. What do we need to step in this automatic process data analysis? Then about some details about the analysis itself. Then Daniel will show you some practical examples just to give you an idea what we can do with this tool, with this analysis. At the end, we will summarize the advantages for you as our customers, and I will show you also some possibilities which we offer as a service within this field. So let's step into the presentation, into the details. As I said, the field of process data analysis, process data itself is a huge field and is a very complex theme. So I would like to start with a very suitable comparison, in my opinion. So if we are talking about, let's say, the material analysis in steel, for example, we take today a microscope with a magnification of 100. So if we're talking about process analyzation, we are able to look into the material, we see some details, we are able to understand what is going on up to a certain level. Yeah? If we want to go deeper, it's just not possible. If we are talking about process analyzation today, automatical process analyzation in cutting tools, I would like to compare it with a scanning electron microscope with a magnification of 500. So it gives us much more possibilities to look into the material, to understand what is going on deep in the material. So this gives us much more possibilities to understand what is going on in the process, finally in the product, and how to change it, how to optimize it. So this is the basis of process data analyzation, process data optimization. What is this in our field of tooling operation? If we want to analyze and optimize our processes today within machining, normally we have several opportunities, several possibilities to do that. On the one hand, we are able to measure the parts with 3D machines, with surface measuring devices, whatever. On the other hand, we have the possibility to evaluate our tool wear. Yeah? But, and this is very important with this, both and every possibility to analyze the process, we call it as one-dimensional. So this means even if we're talking about measuring or also tool wear, we are also looking at one dimension, one piece of the part, let's say like this. On top of that, both and every one-dimensional process analyzing is always available after some time. If we want to measure, we have to put the part into the quality department. We have to wait hours, we have to wait days or weeks until we have some results. And the same is for tool wear. Normally, we don't have a result after one part. We have to wait 100, 200, 300 parts until we get some marks on the tool and until we can understand what is going on in the process. So today, and this is the main fact and the main message of this web session, we want to give you a tool which is similar to the electron microscope with a bigger magnification. We want to give you a software tool which is connected to your machine, which makes it possible to take out a lot of parameters, a lot of information directly from the machine, analyze it, and give you the possibility and the opportunity to understand your process and to optimize it finally. How do we do that? We basically have developed our own software for that. We call it the Gühring Tool Management Software, short GTMS. And on the next pages, you will see more details on that. So first thing, for sure, what we need to get some data, we need a production machine. So normally this is a CNC machine with a control. Then we need a control with an interface. This is clear. We need some connection to a PC system or a laptop with our software on that. And that's basically everything. For the machine, you have to know that normally new machines, they have already interfaces ready to get out the data. Older machines may be upgraded with some hardware, but in general, it should be possible. So we have connected our software to the machine, and we start to get out data. Which data do we get out? The possible data for sure is all parameters, all sensor data, which is controlled, which is included in the machine, such as speeds, feeds, power consumption, positioning data, error messages, main and idle times for sure, and C program code, and so on. So this is all data you see from the machine, which we are taking out, which we are saving in our software, and which we can show you in a graphic way what is going on. On the next slide, I would like to show you the relation between, on the one hand, the process data, and on the other hand, the process influencing factors like tool wear, vibrations, geometrical deviations, material anomalies, temperature fluctuations, and so on. So this is what we say the global view on the process, because on the one hand, when we have a lot of process data, which is influencing our process factors. And from this point of view, we see that there are a lot of data coming out of the machine, influencing a lot of details on the part. So this together gives you, let's say, the full view on the process. This is what we want to show you with the next practical examples. Therefore, I will show you now a very short movie of a pretty easy and pretty simple operation, just to show you the possibilities, what is coming out of that. So that's why we took a very easy operation to show you what is going on and what pretty interesting results we got out of that. So I will start the film now. Can you hear me?
Yes, Marcello, we can hear you, but the film has stopped.
Yeah, the film is okay like that. So again, I will give the word now to my fellow speaker, Daniel, and he will show you the results and the analysis of this short movie and this operation.
Thank you, Marcello. So, ladies and gentlemen, as Marcello already explained to you and showed the short video to you, as far as I see, it's still the video ongoing. I think Marcello will fix this
interruption. We still see the movie. You have to go back. You have to close the movie and go back to the slides, please.
So the video what we have shown to you was the operation drilling benchmark.
Is it not? No, still not.
No,
okay.
It's still not available.
Where is the movie? Yeah.
Ladies and gentlemen, we just have some technical problems, but that's life. This is quite abnormal. So I think we will fix that in a few seconds. So please hold on. So my colleague Marcello will jump directly into the presentation.
Is it now okay?
Yeah, now we are back.
Now it's back.
Okay,
Yeah,
sorry.
Thank you, Marcello. So in the video clip before, we have seen just a short cutout of a drilling operation benchmark we performed together with the micro machine manufacturer Zorn at the Lake of Constance. The target was here to reduce the cycle time, and we did a test with a 2-fluted drill and a 3-fluted drill. Here, the tricky thing was that we're talking about the micro machine. So small machine, smaller spindle. So everybody was afraid of that we will overload with the 3-fluted drill where we want to use to optimize the cycle time, our spindle load. So what you can see in the chart, actually, we made the analyzation with our GTMS of the 2-fluted drill. This shows you the red graph. Here we have a spindle load approximately about 30%. And then we used the 3-fluted drill to compare as well the spindle load. And we were all excited because the spindle load was just 50%. So what we expected at the beginning and where we all were afraid about it is we will overload the spindle, but we could show it in an easy way after a few holes that we will not overload the spindle. So this made it actually for us that we could optimize the cycle time. In the next page I want to show you is during this operation, we found out that one of the bores wasn't good enough. So we had some quality issues. And as Marcello already mentioned before to you, we are able with our GTMS to show in more details all the spindle loads and the parameters. And we detected the problem on the y-axis. What you can see on the left bottom side here, that we have here some vibrations inside the process. So we analyzed together with the machine builder where came the problem from. So in the next page, actually, you can see some more details. So this is just the y-axis graph we want to show you. The blue graph shows us the 3-fluted drill with a not clamped y-axis. So actually this was the root cause that we had so many vibrations inside of the process. For sure, this was clear by the end of the day because the 3-fluted drill, we had a lot of more spindle load already on the main spindle. So this influenced also the y-axis. So after we clamped in the CNC program, the y-axis, we did the same test again. And you can see this in the orange chart or in the orange graph. After we clamped the y-axis, the process was stable and also the quality was then still okay. So for the next practical example, I would like to show you the digital fingerprint. The digital fingerprint here, I would like to show you on a reaming operation. On the left overview, you can see a graph of a reaming operation with in 8 holes. Everything was here fine. We had no vibrations. The process was qualified. Then the customer contacted us and said, hey, gentlemen, we have a problem with our quality. Actually, the surface quality was out of the tolerance and nobody had a clue about it, where the influence factor came from. So first of all, everybody thought this is coming from the tool itself. So we changed the tool to another spindle. We did the same test again. We found out the problem is not jumping with the tool. So then again, we detected the problem spindle. You can also see, therefore, the red marked positions where you see those vibrations actually in the graph on the right-hand overview. And later on, we were sitting together then with the customer. We analyzed, we discussed the data, where can the problem be coming from? And we came up to the decision that the maintenance will be involved. The maintenance, they checked the spindle, and we found out that by the end of the day that the spindle was damaged. The runout was actually out of the tolerance, and we detected the problem. We could solve the problem afterwards. Yeah, the next practical example I want to show you is a milling operation. Here also, we got contacted by our customer, and the problem was random breakages with the milling cutter we used. So we also installed the GTMS, we downloaded the data, we analyzed the process, and what you can see actually in the graph is here like the spindle load of the main spindle itself. It looks like a roller coaster. Actually, this graph should be straight, absolutely straight without any vibrations. So together with our customer, we analyzed the raw parts. We measured those raw parts, compared it with the drawing of the raw part, and we found out that we have here a really high variation of the casting, which was actually out of the casting tolerance. So for the first step, we just reduced the cutting parameters. We could solve the tool breakages, and on the other hand, our customer get in touch with the casting supplier. They contacted them, got the variations of the casting under control, and then the problem was finally solved, and we could go back to the higher cutting parameters. So in the last practical sample you see now, I just want to show you here some reaming operation out of a cylinder head manufacturing. Here, the example was a counter shrink tool. We had problems with the reaming operation. Also here, we had random problems, and a random problem is always very hard to detect, so nobody knows what's going on. And we also got a call from the customer side. We also installed the GTMS, we downloaded the data, and as you can see here, you have a peak. So more than 10% of the spindle load, which we got detected. And by the end of the day, we found out that the root cause was a chip from the roughing operation before, sometimes fall inside the hole of the reaming operation, which leads to the hole was out of tolerance. Also, this problem was detected by our GTMS with the process data analyzation. And now I'm done with the practical examples. I hope I could give you just a few of what we can do with our tool. And I would like to give now the word back to my colleague Marcello to finish the last few pages. Thank you very much.
Thank you, Daniel. So we really hope that we could give you a brief overview with that, with the possibilities. I would like to summarize, as I said before, the advantages of our Gühring's process data analyzer. So for us, it's absolutely clear that we can give you transparency in your operations with this tool, with the software. We can give you clear analysis and optimization of your processes. Together with this digital fingerprint, we can give you clear documentation of your processes. This means always, as soon as a process is good, as soon as a process is qualified, you can record it, you can do the documentation of it, and as soon as something changes, you will always have transparency and a clear idea what is changing. And this is not only for one parameter, this is valid for all the parameters and all the details of the process. And in general, for sure, it's a general point of giving you optimization in your quality, in your process, in the end, finally, to optimize the quality and reduce your costs. So, as I said, we do this also as a service. We provide this process data analysis as a service for you. If you have any problems in your production, if you have any problems with your costs, with your machine, with your tool, or if you want to bring transparency in general into your process, you can call us. We will make a feasibility study of your machine, if it's possible or not. As soon as we do that, we will make a complete process study. Then we will be ready to do the data collection, so we can take out the data from the machine into our software. Then we make the data analysis, and in the end, we will present you an optimization proposal in order to save costs to optimize your production. So that's it. I would like to thank you, all of you. If you have questions, our contact details are in the METAV website. So if not, you can contact us also through our webpage, for example. We are always open to any questions, and we would be happy if we find some interest with you. Don't hesitate to contact us. Thank you from my side.
Also, thank you from my side.
And that's it. Thank you. If there are any questions, let's check it.
Thank you, Marcello, and also Daniel, for the examples. That was an interesting presentation. Process optimization is always welcomed by the users, I think. And we have, of course, 1 or 2 questions here. I think the first question belongs to slide number 14 and addresses the vibration in the y-axis. The question the question is, was it resulting in some kind of noise?
No, absolutely. No, I will give the word to Daniel. Did you hear the question?
No, I didn't hear it. Maybe you can repeat it again.
Okay, so I will repeat it because we have some issues with our loudspeaker here. The resulting vibrations from the test with Companyson in the y-axis, did you hear it? Was it some kind of noisy or not?
Actually, you heard nothing during the test. That was the weird thing.
So could you hear it? Is the question answered with that?
I think so. He said that he heard nothing during the test, but there are more questions arriving now.
Yes, we didn't hear nothing.
Can you read them? Will you read them out, Marcello?
Sorry?
Will you read the questions? Do you have the window with the questions opened? Or shall I read them?
Yes, I have it. Oh, okay. There was a lot of questions. Very nice. So the first question is, will the movie be played? I think yes. As far as I know, it will be played on YouTube. Correct, Mr. Bell?
Yes. Okay.
Yes.
The movie, the film with the presentation afterwards.
Yes. The slide. Will you share the slides with us? Is another question. This is also absolutely no problem. Just contact us. We will send you the presentation. Then the next question is, which CNC controllers work with this software? This is a question I will give to Daniel.
Actually, as Marcello already said, we need to make a visibility study of it. But what we can tell you is actually the Siemens controllers, the newer versions, like the 840D and the 840D solution line, should be normally no problem to get out those data.
So the next question is, will the software be free? I assume this is regarding costs. Unfortunately, no. For sure, we have to charge some costs, but I am absolutely sure that the cost effectiveness is absolutely interested for you. So I would like to invite you to contact us. We will make you a personal offer, and everyone of us will be happy. Then we have another question. Is it possible to have a sort of live monitoring of the process? This is a question I will give back to Daniel.
Thank you, Marcello. Currently, we are working on this live tracking software, but it will be available in a future time.
All right, so we are through with the questions.
Yes, then thank you again, Daniel and Marcello.
You're welcome.
You're welcome.
And we should end this with a few final words. As you might know, the web sessions here are originating from the situation that METAV Fair had to be postponed due to the worldwide COVID-19 disease, and it will be now taking place at the end of March in 2021 in Düsseldorf. Maybe we have the chance to see us there or at any future venue, such as the next METAV web sessions. I wish you all a pleasant stay, and thanks again to Gühring with Marcello Mindrone and Daniel König. You can find the agenda of the upcoming web sessions on the website IndustryArena.com, and all participants can also find a participation certificate in the webinar planning tool for download. Thank you again and goodbye.
Thank you. Bye-bye.
Thank you. Bye.